Hello, this is Mr. Stansbury. I'm going to take you through the notes on stationary points. At the end of this, you should be able to say, I can find and classify all stationary points of a function. So first things first, let's talk about what a stationary point is. Stationary point of a function is where the derivative equals 0. So the slope of the tangent line, slope of the tangent is 0, which is otherwise known as, also known as, a maximum, a minimum, or what we call a stationary inflection. We'll talk about this here in a second. Okay, so first thing, there's different kinds of minimums and maximums. A global minimum is the lowest point of the graph on the function. The global maximum is the highest point of the graph of the function. And then a local minimum is the lowest point in the area of the graph of the function, and a local maximum is the highest point in the area of the graph of the function. Easiest way to understand this is to take a look, say, at this graph here. So this point is above that point, this point is below that point. So what we do is this one here, this is the lowest. We'll start with the one on the left here. This is the lowest that this graph will ever get. There's no other point on this graph. If it begins here and ends there, there's no other point on this graph where it's lower. So this is called a global minimum, the lowest this graph will ever be. Okay. This one here is actually called a local minimum because it's the lowest in this area here. In this area, that's the lowest point, but it's not lower than that point. So that's just called a local minimum. This here is called the global maximum because it's the highest that this graph will ever get at any point. And this is called a local maximum because this is the highest that this graph gets in this general area right here, but it's not the highest the graph will ever get because that's where the global maximum is. Okay? Hopefully that makes a little bit of sense as to what local and global minimums and maximums are. As far as a stationary inflection is when the tangent to the graph, or the derivative equals 0, but it's not a minimum or a maximum. So for example, this is the graph y equals x cubed. Right here, the tangent at this point would actually be 0, but it's not a minimum or a maximum because it's going up, 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 and then it just happens to flatten out right at this one spot here, and then it continues to go up. So this here is called a stationary inflection. Okay, kind of a unique thing that doesn't happen a lot, but it's out there, so it's important to talk about. Okay, we are going to make the sign diagram for the following graph. Okay, so sign diagram is basically, is it increasing or decreasing? So let's see, right here, we know from here to here, this is decreasing. From here to this next point here, it's increasing. And then this one here to this next stationary point is decreasing. And then it's also decreasing after that. Okay? So what we do for a sign diagram is we just put all of those x values in there. It doesn't have to necessarily be to scale, but the first x value, -4. And then and these are all of our stationary points here. X value here is at 2. And x value here is at 5. So to the left of this -4 value, so basically it's this point, and this point right here. So to the left of this line over here, this thing is decreasing. So the sign diagram is going to be negative over here. And then when this, between -4 and 2 right here, this graph is increasing. So we're going to put a positive right there. And then from 2 to 5, this thing is decreasing. So between 2 and 5, this is decreasing. And then after 5, it's still decreasing. So we'll put actually another negative in here. And this is called a sign diagram. Okay? It basically tells you if things are increasing or decreasing. So this is decreasing up until x is -4. It's increasing between -4 and 2. And then it's decreasing from 2 to 5, which this here, since these are both negative, this is going to be our point of inflection there. Stationary inflection, sorry. Misnamed that. Okay, stationary inflection right there. And then it's going to, after x is 5, when x is greater than 5, then this thing is still decreasing. Okay? So here's what we're going to do. Example 7, find and classify all stationary points of this graph here. Now, two ways we can do this. We can take the derivative of this, set it equal to 0, find all the x values for when this thing equals 0. That's completely legitimate way to do that. But again, we're going to go with the smarter, not harder route here. And since we are able to use our graphing calculator at any point on any of our tests and any of the IB tests, we're going to do it here. So here's what we're going to do. We're just going to enter this graph into our graphing calculator here. Okay, so here's our function. We enter that in the graphing calculator. We're going to just simply hit graph. Oops, I forgot that from the last time here I had adjusted my scales here, so I'm going to let it finish graphing. Although actually this worked out pretty nice. Normally we would have had this back at, let's see, sorry, this is stalling here a little bit. Normally we have this at 6, zoom standard. And then when we have this graph here, oops, it should be already graphing. Yeah, notice we can see the minimum point, but we can't see that maximum. So what we'd want to do on the window here is we want to see higher up, so we got to increase our Y max. For the most part, we shouldn't really have to worry about decreasing anything else. It should still be okay, but we can just increase our Y max, and we can see both turning points here. So we've got a turning point there and a turning point there. No stationary inflections that we see. So all we need to do is find that point there and that point there, right? Because it just says find and classify all stationary points of this graph here. So I'm going to just do this. I'm just going to kind of sketch this graph in here. Looks something like that. And sketch means truly just that. It just means sketch. Okay, so we're going to put the coordinates for this point in and that point in. And we already know that, see, this here is a local minimum because over here it's lower. So this is a local minimum because it says find and classify. And this point up here, it's a maximum in this area, but it actually gets higher up over here. So this is a local maximum as well. Okay, so then now we just use our graphing calculator to find those 2 points. Second trace. First one we want to find is this minimum. So we go down to minimum. Go a little bit to the left of that minimum. Enter. Go a little bit to the right of that minimum. That looks good enough. Push enter, and it's going to give us that minimum point right there, which is at 0.13 and 4.87. Okay, so there's our local minimum, and then we can do the same thing to find the maximum. Second trace, go down to maximum, push enter, get over close-ish to that. That's plenty close. And I got to go past that for sure. I want to go definitely past it just to make sure that I'm good. There we go. That's definitely passed. Push enter, and it's going to find the highest point in here. Highest Y value, and that's 2.54 and 18.76. 18.76 is the max right there. Okay, so find and classify all stationary points of this graph. Look, there we go. We did. There were 2 stationary points in there, and one's a local max, one's a local minimum. Okay? All right, got one last one to take a look at here. But before we do that, let's do a quick comedy break.
So I really don't like happiness and touching right now. I think it's stupid. I think that's mostly why you getting on my nerves, sir. I feel like you holding her like she gonna run, and that's kidnapping. That's illegal, sir.
Okay, that's all we have for this section. If you have any further questions, please feel free to ask. Thanks.